Here's the diagram that makes it so much easier to convert moles to particles, or moles to liters, or moles to grams, or grams to moles, particles to moles, liters, and so on and so forth. So, for example, we're trying to convert particles to moles. I also like to think about the fact that every time the arrow is going to point at moles, there's a division sign, so we have to divide, and every time an arrow is pointing away from moles, multiplication is involved. So let's say we need to get the grams converted from moles. So for moles, let's say to turn into grams, we'd have to do this. We'd have to do, according to this, moles times molar mass, output mm, just to make it easier. When we multiply moles to molar mass, we get grams. So that would be grams. However, if we want grams to turn into moles, all we have to do for that is by grams to the molar mass. And then we have the moles. So next, if let's say we're trying to figure out moles to liters, moles is being converted to something else, I think about the fact that that implies multiplying. So moles multiplied by 22.4, and that would give us liters. And to get, let's say we have liters already, we're trying to get moles, so then we would have to divide liters by 22.4, and so on and so forth. The same could be said about particles. But what happens if we want to go from particles to liters? So based on this diagram, first we'd have to convert particles to moles. And for particles to convert to moles, we would divide the particles divided by 6.022 times 1023, which is Avogadro's number. We'd have to do that first. Then we get the moles in that case. And then for moles to be converted to liters, all we'd have to do is multiply it to 22.4, and then we get liters. So this is a great diagram to try to remember the process of conversion from moles, particles, grams, and liters.